Right? This video is about our final project in Python, which is Buffalo Crime Analysis. Our team members are Arvind, Sudhanshu, myself, Gautam, and Swaroop. This is our task list. We started our project by April 30th and we completed it by May 17th. I'll be giving you a brief explanation of our list in the coming portions. To give you an introduction of our project, we are going to compare the crime rate in city of Buffalo with the median income level and the population density of the city. The analysis steps were data retrieval and pre-processing, wherein we get the data from an API and then we select the specific columns needed for analysis. And we also eliminated the NA values wherever necessary. And the next step was data visualization and exploratory analysis, where we had to plot three heat maps, one for each data, which is crime rate, the median income level, and the population density. And we also had to plot a line graph, which shows the temperature compared to the crime rate. The references that we took for this project were from two APIs, one from buffalony.gov, the other one from census.gov. We also had help from ChatGPT. These are all the prompts that we used. The basic requirements to run this code are to install all these packages along with GeoPlot and GeoPandas. So you will have to install the GeoPandas environment in your Anaconda using this link. From which you will have to run Jupyter Notes and then access this code. And you will also have to download the Census API key from this link and then install it in your system environment, which will help you in running this code. Coming to our code, we have saved our code in the name of crime-data-analysis.py, for which the link I've attached in this README as well. As I told you earlier, starting step is to install the required libraries and then call the API to get for the specified year. Then it filters data to get columns required for visualization. As you can see here, we have selected only 4 columns which we need for visualization. One is incident date time, incident type, latitude and longitude. And we have assigned weights based on the intensity of the crime in this library. The dictionary. So we have given the least weight for crimes like theft and larceny, and then murder being the highest weight. Now, this code block retrieves street network data and geographical boundary information for Buffalo using the OSMNX library. It converts crime data stored in a data frame into a geodata frame, associating latitude and longitude points with the corresponding attribute data. The street network data is also converted into a geodata frame for visualization purposes. Additionally, the code assigns weights to the crime incidents based on a predefined dictionary, as I told you earlier, and converts the latitude and longitude columns to numeric data types for further analysis. And we've also taken a custom color map. So the existing color map was not enough to segregate the data clearly. So we took a custom color map. That is what you can see here. And the next code block visualizes a crime heat map of Buffalo NY. It sets up a projection for the base map and converts the geodata frame to the web Mercator projection. The code then creates a plot with the streets and outline of Buffalo City, overlays a kernel density plot of crime incidents using latitude and longitude coordinates, and adjusts the plot's aesthetics such as bandwidth, color map, transparency, and legend. The map limits and control to focus on the city area, and a color bar is added to represent the crime intensity. A background image is added using the contextually library, and the plot is finalized with a title and axis label before displaying it. So talking about kernel density estimation, this is what we've done. So it converts these points into a gradient like this. And we've also removed outliers which were outside the Buffalo City. This is how our plot looks like. As we can see here, the red indicates the highest crime areas, and then the green indicates the least. Now coming to the median income plot. So we will perform a simple visual analysis by comparing the median income of areas with the crime rates. So that is why we are plotting this graph. Since we already have a graph with crime intensity by geographical area, we will plot another graph that has the median income level by geographical areas. Then we will perform visual analysis by comparing these two graphs. So in the below code block, we will find the data frame that has GeoID along with median income for each census tract. As you can see here, we have GeoID and median income. So what happens, this code block is to get geographical information to plot these incomes on the map. We get this information from topologically integrated geographic encoding and referencing. And then our map looks like this. So what you see here is the entire Erie County, and what we need is only the Buffalo area. So what we're doing is we are creating a polygon that covers only the Buffalo area. And by doing so, we get the geometry for the polygon and then the median income and GeoID only specific to the Buffalo area. So that is why it is 78 rows when compared to the 230 rows, which is entire Erie County. And this is how our map looks like. Here, what we've done is we have inverted the color code. So wherein a red indicates lowest income level and the blue indicates highest income level. Coming to the third part of our project, what we have done here is we have created a similar heat map for population as well. That is what this code block does. So as you can see here, the median income column is replaced with the population and their respective GeoID and geometry. And it plots a graph for the population density here. So here, red indicates highest population and blue indicates lowest population. And finally, what we have done is we have plotted a line graph that compares temperature to the crime intensity. That brings us to the results of our analysis. So as you can see here, the crime rate is basically high in 4 areas, which is Ellicott, Niagara, Maeston, and University. So comparing the crime rate, income, and population in these areas, we see Ellicott has a mix of high, low, and medium income level and medium to low population. Particularly in the downtown area, the income is high and the population is low. This can indicate that floating population at downtown that have a high income level. And Niagara, it has close to medium income level and medium population level. The university area has close to medium income level and high population. The Maeston has close to medium income level and medium population. So from our analysis, we can say that there is no strong correlation between crime rate and income, and also the population level. Now, comparing the temperature and the crime rate. So as we can see here, there is a strong correlation between the temperature and the crime rate. So the crime rate is few during the winter and it is higher during summer. So as we can see, the along with the temperature, the crime rate also increases as the temperature increases here. Coming to the future scope, from this analysis, it appears that additional factors beyond income and population need to be considered to understand the crime rates in these areas more comprehensively. Other factors such as education levels, employment opportunities, community resources, social issues, and law enforcement could also play a role in shaping the crime rates. Further investigation and analysis are necessary to identify the underlying factors contributing to the crime rates in these areas accurately. So, given the data, we can actually plot similar graphs, and then we can come up with the correlation between the factors like employment opportunities or the community resources, the social issues, or even the education levels of the areas. That brings us to the end of the presentation. Thank you.